Welcome to Visual Development and Audio Design course. This course is broken down into 4 modules: Art Styles, Animation, 3D Models, VFX and Audio Design. We will review many of the basics in these categories, while also starting a new game project for the journey that will be improved upon the following courses 6, 7, and 8. You can think of these steps we take here as creating the core components needed to start iterating on game design in the final course: game development and prototyping. We'll explore art styles, camera features, and stylistic choices. Our project will use stylized Egypt level as a base, where we find ways to elevate and revamp for our game design needs. We will integrate an initial kit of animations with mobility actions such as dodge roll, air dash, and double jump. Add various 3D models to the project to prototype with. Review how 3D models are created from start to finish and the optimization techniques. Learn about the VFX systems in Unreal Engine called Niagara. And discover how to implement audio design techniques for ambiance, music, and sound effects. These stepping stones will progress towards our end goal of creating 6 small game experiences: stealth survival, platformer, capture the flag, action combat, crafting, and story. So, let's get our creative juices flowing. Hello and welcome to the Art Style Overview. In this module, we will identify the massive range at which game art can be We will examine differences of realism for stylized looks. Identify the main camera perspectives used in today's games.
So instinctive and so passionate. Every word I move so descriptive like an adjective. I got a vendetta against people who patented being negative.
Review camera mechanics that can enhance gameplay feel.
I got facts over tracks, this and that, spitting slow, spitting fast. I could roast, I could gas, think I'm
Find
okay.
systems within Unreal Engine that enable specific stylistic choices.
A reflection of the emptiness, hilarious. You think you're worth my time, you're delirious, mysterious because you hide behind a fake exterior.
And discover how lighting is used in gameplay.
Superior, get off of me. This ain't no humble brag. I want you to hear words, you can say them back. I want you to feel free from the chains at last.
So,
and to believe in
I'd have
what
to
you
say,
got, it was built to last. Yeah.
Let's get creative.
I never got anyone.
It's time to see what's next.
Choosing an art style for a game can have a dramatic impact on game design and who the target audience is. Many players have a common aesthetic that they prefer. As a quick exercise, think of game genres and the common art styles that they choose. The vast majority of horror games lean heavy into realism, while many platformers lean heavy into stylized art. Technical shooters often use realism. Arena or hero shooters lean towards stylization. You can think of art style as a scale. One side is hyperrealism, and the other side, you have a fully stylized art style. Unreal Engine has had a huge leaps in realism, most notably for the realism and release of the metahumans. At the same time, Fortnite has a hybrid realism and stylized approach and sits closer towards the middle. The plucky Squire is extremely stylized, with such cute and adorable shapes and bright colors, and just overall great aesthetic. Many times an art style can be chosen based on budget, time frame, and many other decisions in between. While characters, environment, and user interface can have different approaches to their style, It all still has to work together for a cohesive vision that brings the core game to life. The art direction of games in development can sometimes become a political topic within the company. These decisions should ultimately be left to the art team and, in many cases, the art director to have the final say on what works. In many aspects of game development, a Venn diagram or something similar will be used in the efforts to portray a vision for the project. This can be in relation to the overall game design or specific categories such as art style. Creating something unique and interesting is something all game developers strive for. Art style is constantly tweaked and iterated throughout development to make a cohesive aesthetic. Games can be beautiful, terrifying, and amazing. The worlds we make have infinite possibilities to create and explore. Ultimately, the power is in your hands.
Let's take a look at major camera perspectives used across games. Third-person perspective is when the camera is positioned behind the character. This gives a larger view of the environment around the character and a clear view of your character's actions. In the case of third-person shooters, the camera is pulled in closer and offset from the shoulder, with the crosshair in the middle of the screen. This still lets the player have a clear view of their character, but aligns the player aiming with the center of the screen. First-person perspective is when you have the camera positioned directly where the character's eyes would be. There are two nuances to a first-person setup. In the default Unreal Engine first-person example, there's a camera with floating arms. This is the default way of executing first-person. When you pick up a gun, animations are applied to the floating arms that hold the gun, that is visible by the player camera. If we look at this from a different point of view, we can see what is happening. If you were to look down at your feet, you'd see nothing, because your body isn't there. This brings us to the true first-person setup, where the whole body is visible when looking down. True first-person can have additional work required to make sure animations don't clip through the camera, or for the head bob while walking to not induce motion sickness. Side-scroller is one of the classic camera perspectives where you view the side of your character on a 2D plane. You can only move left, right, up, and down. The camera will follow the character and give a good indication of obstacles and enemies around you. In our modern era, both 2D and 3D games are pushing the boundaries of what side-scrollers can become. Now on to isometric and top-down. These two perspectives are often grouped into each other and have very similar camera angles. The part that they have in common is that the camera is pointed downward at the player at a 45-degree angle. Note that this angle is just a guideline, and many games will have slight adjustments to the camera angle to do what's right for that particular game. The next part is that isometric typically means the use of an orthographic camera. While there are some technical details behind an orthographic camera, the core design component is that it removes depth and perspective. If you look at the grid lines on the ground, they are parallel and will never cross over to each other even when at the far sides of the screen. You will also notice the angle of the camera is usually shifted to be at a 45-degree angle to the world. Compare this to top-down perspective, where the camera is at a straight-on angle with the world. I'm sure many of us have fond memories of running around pixel games using this perspective. While not technically isometric, the action RPG genre often gets grouped into this category. You will notice it is essentially the same angle as top-down, but without the orthographic camera. Perspective and depth does actually exist in this view. This last camera angle is also considered top-down, but the correct terminology would be a satellite perspective, looking straight down on the character and the world around them. While each game you play will have a primary camera perspective, pay attention to how games use perspective changes for minigames, puzzles, power-up abilities, vehicles, telescopes, storytelling, and more. Camera mechanics can play a major role in game design. Let's review various systems you can use to add game feel and a sense of immersion. The most obvious one being camera shake. Camera shake can add a tremendous amount of impact to any action. It can be added in different variations as well. A low rumble on the charge of a fireball, with a heavier shake when a target is hit. You can even have the weight of the camera shake relative to the amount of damage dealt. Get a critical hit, you can have a bigger camera shake. Maybe you miss your target, and there's no camera shake at all. The camera shake can be very subtle, too. Always keep in mind that camera shake when done wrong can in fact cause motion sickness. Especially in VR. Don't use camera shake in VR. Camera lag is used to create a smoother transition as you control your character. There are two main types of camera lag, position-based and rotational. Here's an example of no camera lag. The camera is instantly following and turning in the controlled direction. Now we'll start with rotational lag. You can notice the character rotates ahead of the camera and it will quickly catch up to the resting position. It has a bit of a sway feeling as the character moves around. Now let's add positional camera lag. As the character moves forward, the camera stays behind ever so slightly. Then, as the character stops, the camera takes a second to catch up with the character. Camera lag is all about the game feel of a character. It can give a bit of a feeling of smoothness with the camera. These settings can be tweaked to get what feels right for the game. It is never a one-fits-all solution, and some games may choose not to use camera lag at all. Field of view is a way to distort the range of view for your camera. In this example, I'm raising the field of view to a high value, and then lowering it down to a low value. In games, this is mostly tied to mobility, effects like sprinting, dashing, or driving really fast. It is a common way to portray a burst of speed. Camera quality can also become a gameplay mechanic, typically used to disorient the player, such as a flash or a concussion grenade that whites out the screen. Blur effects can also be used to create these changes. The final camera mechanic we will review is how it can affect optimization. If you are in a third-person or first-person perspective, you have a full camera rotation to look around and see objects at all directions. This can require a higher level of performance as there are more objects visible to be rendered. Characters are also closer to the camera, which means players will be more likely to notice flaws, issues, or lack of detail with the models. In other perspectives, such as top-down or isometric, you can more effectively evaluate how many objects will be on the screen at one time. Since the player can't look off into the distant sunset, it's a much more controlled visual experience from an optimization standpoint. Characters are also farther away from the camera, which can require less detail to achieve a great visual look. These are just a few of the important camera mechanics that can add great value to your gameplay experience.
When thinking about the visual aesthetic of the game, there are many features you can use to create an interesting look. A post-process volume is one method to make global or regional changes to the look of the world. Everything from camera changes, bloom, chromatic aberration, exposure, depth of field, and color grading. Color grading is common to create underwater effects. Some games will also limit their game to set an amount of colors. This will create a locked color palette to choose from when creating art. Through the saturation value, you can quickly create a black and white look. A post-process volume can be set to unbound, which will make it apply to the entire world. When unbound is not checked, changes will apply when the camera walks into the volume. Post-process materials are one way to create a cartoony, cell shading, or comic-style filters. Another common material is for creating a pixelated look. In Unreal Engine, you can use custom depth stencils, combined with post-process materials that will allow you to create outlines around a character. These are just a few of the technical features that can help a team achieve the art style they're looking for.
This has to be the right way.
Lumen is a new technology in Unreal Engine that has brought incredible lighting techniques. But lighting isn't just for atmosphere and visual appearance. Lighting is a key way to guide a player throughout an area or highlight points of interest. Let's break down how this world uses light to guide a player. In this scene, the path the player needs to travel is very clearly lit. And at the same time, when a game designer is telling you where to go, it could also be a form of misdirection. In the cove below could be an area where additional loot, traps, or secrets for the players to discover. Here, there is a clear emphasis on the cliffs above, signaling to the player that they will have to find a way up. That could be looking for a cliff you can climb up, or maybe there's a rope you can use. Maybe there's a pair of rocks that are conveniently close together, allowing you to wall jump back and forth. Notice in the scene, lighting is used to highlight this point of interest. As the player walks towards the statue, it could be both good or bad. The statue could come to life and, I don't know, initiate a boss encounter. Or it could be where you collect your first spear and shield for the challenges ahead. Highlighting an element also doesn't have to be super obvious either. It could be subtle, like a soft glow. You can start trickling down some breadcrumbs for different objects throughout your game and balancing which ones stand out. This is a huge part of the iteration process. Or be extremely obvious where you need to go when you want to ensure the player won't get hurt. Or don't. Ultimately, this is up to you and your team about what kind of experience you're trying to get the player to see. But ultimately, lighting can be an incredible game design tool to help guide your players through your game, whether you want them to be scared or happy or whatever you choose. While at this time, lighting can be a form of misdirection to keep secrets hidden away, but it also can be a really great way to bring in lots of clues and puzzles.
It's open. Don't fail me now. It's time to see what's next.
Hi, I'm Kristen.
And I'm Christopher.
We wanted to take a minute to talk about our experience as game developers and using Unreal Engine.
And without further ado, let's get into it.
We are two-time Epic Mega Grant recipients for creating Vertical Third, a massive game architecture available on Unreal Engine Marketplace. Vertical Third features a no-code workflow with designer tools already complete through data tables.
Additional features are questing, loot, inventory, equipment, experience, crafting, combat, kit bash cosmetics, spawners, AI, game options, scoreboard, user interface, and more. All of which has video documentation on the Vertical Third YouTube channel.
We've appeared on the Unreal Engine livestream with our 3-hour overview on many of our features Vertical Third has to offer.
We have an online tech demo on the Epic Game Store that we modify with our own proprietary patcher and launcher. One highlight feature is our auto-detect multiplayer. We're playing online with dedicated servers, listen servers, and single player, all utilize the same code.
In addition, we have been working with Epic Games on educational content. Our first project was the UEFN Boba Shop, a course on 3D modeling tools in the Unreal Editor, available in both UEFN and Unreal Engine.
You may have seen some of our behind-the-scenes past work on the Unreal Engine livestream, such as early stages of Vertical Third, Wandering Wisp, a short previs cinematic, and the first cast day, cinematic short and music video.
Full version of each of these are available on our Start Gaming Inc. YouTube channel, along with some of our Game Jam time lapses where we made King of the Hill style online brawlers in under 5 days. These were Castle Day and Squishums and the Mercat Moon.
Working in Unreal Engine has allowed us to create such amazing worlds.
We are so happy to share our experience and have the opportunity to create this course, and we can't wait to see what everyone makes. So, let's get creative. Congratulations on making it through the art style module. Let's review what we've learned. We discussed how the choices of art direction can impact your target audience. We looked at the core camera perspectives used in games such as first person and true first person, third person and third person shooters, side scrollers, and a range of views in isometric and top down. Looked at camera mechanics like camera shake, camera lag, field of view, and camera quality. Identified technical features to make stylistic choices through post-process volumes, and post-process materials, and custom depth stencil. Finally, how to use lighting in game design to lead or misdirect a player. And ultimately, you're one step closer to making your vision of your game come to life. Welcome to the animation overview. In this module, we will cover the essentials to animation and how they truly breathe life into your games. The connection through combat and storytelling can capture your audience that will allow the worlds we create to be incredibly impactful. We will review the core systems used in Unreal Engine by breaking down the technical features that blend animations smoothly. By the end of this module, we will create a new game project where we implement Mixamo animations for future prototyping different game designs. So, I'd have to say, let's get moving.
An animation blueprint is a script that defines which animations should be chosen to play and blend through. In other areas of development, they are also known as state machines. An animation blueprint consists of two sections, the event graph and the animation graph, or anim graph for short. The event runs every frame and is constantly checking your character for changes. When a change is found, it will update the local variables you set up and define. In this example, we are checking the speed of the character, if they are moving or standing still, and if they are falling, in what direction they are moving. This then allows the animation graph to use those variables to make decisions on which animation should be played. In the animation graph, you set up different states for animation. Here we set up a locomotion state, which is a fancy word for your run, walk, jump, and other movement-oriented cycles. Then you set up rules to allow the flow between these states. If the character is standing still, it will play the idle animation. Once the character reaches a high speed, it will flow to the forward run animation. If the character jumps, it will flow from a jump up animation to a fall animation to a land animation, and finally back to a run. This is the animation blueprint and is the main driver of smooth animation blending in Unreal Engine.
We're going to give a quick overview of some of the technical features for game animation in the Unreal Engine. An animation sequence is a single animation asset. These can be created in external 3D modeling programs such as Blender, 3D Studio Max, or Maya. More recently, Unreal Engine has built-in animation features to rig skeletons and animate all within the Unreal Engine. Once an animation has been created or downloaded from the marketplace, You can drag and drop the animation into the content browser to import. The most common animation file types are FBX files. When you import your animation, you will have to select a compatible skeleton. When you open an animation sequence in Unreal Engine, there are several windows available. In the bottom right of the list of animation assets available for the skeleton, in the top right are quick links to the skeleton, animation, clothing, animation blueprints for the skeleton. A timeline on the bottom where you add notifies, sound effects, visual effects, and more specific frames of this animation. An event notify allows you to trigger an event on the animation blueprints event graph, where you can place an additional code logic. On the left-hand side of the panel, with these different technical options to change how the animation functions. To group animation sequences together, you can create an animation montage. You'll notice a montage has a blue color, while a sequence is green. An animation montage lets you place multiple sequences in one animation file. This is primarily used for triggered animations by the player, such as mage casting a fireball or initiating a sword attack. You can have all the same controls in animation montage that you do in an animation sequence. You have more control on when each animation sequence starts, ends, and other timing options. Lastly, an animation blend space is a two-direction graph for smooth animation blending. The most common use for run and walk cycles. On the horizontal axis, you have the direction to the character is moving. On the vertical axis, you have the speed of the character is moving. This lets you smoothly transition from walk to running in different directions. How you set the values of speed and direction is on the animation blueprints event graph. We get the speed and direction of the character to save to a variable. Finally, on the animation graph, we drag the animation blend space out and connect those variables to the blend space. As a quick review, Unreal uses the animation sequence as a small clips of animations. Through technical systems, it blends each of these small clips together for a visual smooth animation experience.
There are two other forms of animation that games use. The first is procedural animation. Procedural animation uses physics simulations, code, and in-engine systems to animate in real time. There is no animation sequence or asset used to create the movement of this dragon. Using math and curves that feed into a full-body IK solver, it will lift the dragon's leg in an arc towards a forward position. Through code, the forward position is found through a trace. All of the other bones and joints can then be affected based on the leg's movement. You can then set up different rules, such as don't allow 2 feet to be in the air at the same time. The other components, such as the wings, tail, and tongue, can have physics simulations that cause them to dangle and bounce based on the movement of the body. You can also designate points of interest, such as an apple, to automatically adjust different bone positions of the character. In Unreal Engine, these systems use Control Rig, which is the skeleton and rigging tools to help animate inside the engine. Moving on to the next type of animation, motion capture. Motion capture creates animation data based on the movement in real life. Using physical hardware such as body tracking suits, hand tracking gloves, motion tracking cameras for the body, and face tracking cameras for the expression. Motion capture is heavily utilized to speed up the animation development process. Creating a base animation through motion capture can speed up animation time considerably. From there, you can have an animator clean up and polish the animation towards the style of the game. The fallback, of course, is that these setups can be expensive, requiring a large upfront fee for all of the equipment, and requiring a decent-sized room to be able to properly track your movement. Now, if you can't do your own backflips, you might need to hire motion capture actors to do them for you. While expensive, these setups are empowering a next generation of creators and small teams to create extremely high-quality content. This creator is Xanadu on YouTube and is a one-man show creating really high-quality content. It is extremely inspiring to see how Unreal Engine is empowering even the smallest of teams.
In this video, we're going to set up our Coursera project. This project will be used throughout the rest of the certificate and contribute to the final course, game development and prototyping. Now let's go ahead and launch Unreal Engine. We will be using the game's third-person template, with the target platform set to desktop, quality set to maximum, and include starter content. Let's name our project Coursera_game and hit create. We are going to start with a bit of a folder maintenance to help us stay organized. Right-click on the content folder and click New Folder. Name it Coursera. In the File menu in the top left, select New Level, choose Empty Level, then click Create. Now we can save. Select the Coursera folder and name this to level_transition. Now we will make another folder. This time name it UE for Unreal Engine. This folder will hold the template files from the Unreal Engine. In the UE folder, create a folder labeled Third Person Template. We will move Third Person, Level Prototyping, and Characters folders to the Third Person Template folder. One error will pop up, which we will fix later. When moving files or folders in Unreal Engine, it's very important to follow up by right-clicking on the content folder and selecting Fix Up Redirectors. Now we can delete the empty Level, Prototyping, and Third Person folders that got left behind. Now move the starter content to the UE folder and fix up redirectors once more. We are going to open up the Epic Games launcher and go to Unreal Engine Marketplace. Search for Stylized Egypt and add this to your Coursera_game project. This might take a few minutes to download, so go grab a cup of tea or something. This is going to be our test level through the remaining courses. Once complete, you should see the folder in your project. It will create one folder labeled MP, short for Marketplace. Move the Stylized Egypt folder to the MP folder, and don't forget to fix redirectors once more. Go to the Maps folder under Stylized Egypt and duplicate the level, renaming it to Stylized_Egypt_Coursera. In the Edit menu at the top, go to Project Settings. Click on Maps and Modes, and set the editor startup map to Stylized_Egypt_Coursera. We can now open up the level. To me, this is a great way to start basic testing and being in a world that isn't just a square gray box. You'll notice a few errors at the top left. This next step will take a bit to load, so only start the process during your next break. I will show how to hide the errors as they are not important to fix at this stage. To fix the errors, you can go to the Build menu and select Build Lighting Only. Or you can type Disable All Screen Messages in the console to hide the errors. Now we can go to Window menu at the top, choose World Settings. On the right side panel, expand it so you can see the game mode options. Select the BP_third person game mode. Now we can click the three dots by the play button at the top and click New Editor window, which is also known as Play in Editor. Our project is good to go.
Mixamo is an Adobe product that has thousands of free animations available to download. It is widely used throughout the industry in prototyping. As you get to know the animations, you will even spot them in officially released games. You will need to create an account and log in. Once you log in, you will see an assortment of animations. The first thing we need to do is make sure the default character is set to the Mixamo XBot. Click on the Characters tab at the top and search for XBot. Click this character to set it as the default. Click Download and save it to a location on your computer. There will be quite a few Mixamo files in the future, so it's best to keep them organized by creating a Mixamo folder. In this folder, we'll add a Characters and Animations subfolder. Open the Characters folder and name the file sk_mixamo_xbot. Then we can click Save. If we click back to the Animations tab, you can select an animation to preview it. The Xbot character should be shown on the right to signal that it is set to default. Now we can return to our project, add a folder to the Coursera folder labeled Mixamo, and just like before, we will add two subfolders, Characters and Animations. Inside the character folder, we will import the Xbot character. Keep all the default options and click Import. Save our files, and we can drag out the skeleton into our scene as a preview. We will download the animations for this character and later transfer them to the Manny and Quinn mannequins in Unreal Engine. Our character is ready.
We are going to set up the Mixamo characters blend space. Now, if we head over to Mixamo, let's search for Happy Idol. You'll notice that sometimes Mixamo has animations with the same name. Hovering over them gives a bigger description. In this case, we are going to use the Happy Idol Variation 1. Now let's click Download. Make sure to drop down to Set to Without Skin. This setting will stay until you close out the browser, but always make sure to keep an eye on it. Let's click Download once more. Go to your Mixamo folder. Then go to your Animation folder. Create a new folder named Unarmed. We can name this animation AS_idle. AS stands for Animation Sequence. Our file naming conventions will make a big difference in the long-term duration of this project. We'll touch on this more in a future video. Now we can search for Happy Run. We'll select Run Forward Animation, this time making sure to check on the In Place option. This is an important step for these animations to work in the game's run cycle. Now we can download this animation and name it AS_run_forward. Let's now search for Happy Walk. Click the forward walk, check In Place, download and name it AS_walk_forward. In this same search, we can also download the Happy Walk Backwards animation. Check In Place and name it as AS_walk_back. One part that can be confusing in game animation is the absence of certain animations at times. In this case, there is no run left or right. The Happy Walk cycle has a turn left and a turn right, but not what we need, which is a strafe left and a strafe right. We can combine a different walk cycle to do this. Search for strafe left. Use the left strafe animation that has the Xbot character. Download and name this as AS_run_left. In this same search, we will download the walk left animation and name it as AS_walk_left. We will repeat this for the right side. Search for strafe right and download the right strafe for running and walking. Label them AS_run_right and AS_walk_right. We can go back to our project. Under the Animations folder, create a new folder labeled Unarmed. Hit the Import button and select all of your animation files we downloaded. Select the Mixamo Xbot skeleton and choose Import All. Make sure to save. Now we can create our unarmed blend space. Right-click in the content browser, hover the animation category and select Blend Space. Choose the Mixamo Xbot skeleton. Name this BS_unarmed. Now let's double-click to open it up. We will now set up the graph, which will determine how these animations blend together. Our horizontal axis will be direction. Our vertical axis will be speed. Direction will have the value of negative 180 to positive 180 with 8 grid points. Speed will have a value of 400 with 2 grid points. Now we will plop our animations into the graph and then right-click them to type in precise placement. We will start with run forward in the top middle at 0 rotation and 400 speed. Now we will skip a line to negative 90 degrees for run left. Let's put this at 400 speed. The opposite side will be 90 degrees for run right and 400 speed. We will be implementing a backwards movement penalty. So we will place walk back at positive 180 and negative 180 degrees for both 400 and 200 move speed, a total of 4 times. Now walk left at negative 90 degrees and 200 move speed. And walk right at positive 90 degrees with 200 move speed. And finally walk forward at 0 degrees and 200 move speed. If you hold Control down and mouse over the graph, you can see how the character will blend during movement. The direction and speed will be controlled by the animation blueprint, which is our next step, so let's go!
Now that we have our animation blend space in place, we can properly create our animation blueprint. Go to our Mixamo folder, right-click, hover over the animation category, and click Create Animation Blueprint. Select the SK Mixamo XBot skeleton and hit Create. You can name this ABP_Mixamo_XBot. Save the file and open it. If needed, drag the tab into the top bar. In an animation blueprint, there are 2 graphs to work out of. The animation graph, which handles how animations blend together based on different states, and the event graph, which handles code-related functionality, which includes setting those states. We will start with the event graph. Right-click and search for Event Initialize Begin Play. When this animation blueprint activates on a character, this event will trigger. Now we can right-click and search for Get Owning Actor node. Drag off the pin and search for Cast to Character. We can connect this with the event. Now right-click the character pin and promote to variable. Name it Character. This variable is a reference to the character that is active on. Let's make a quick comment noting this. It's always good to keep up with your comments to make sure your code is readable. We can safely delete the try_get_pawn owner node. Click and drag the character variable to the graph and choose Get. Now we will right-click the variable and choose a Convert to Validated Get. This will make sure the character is valid before moving forward. This section of the graph is updated every frame. It will set important variables required for the animation graph. Let's drag off the character pin and search for Get Velocity. This is the speed that the character is moving. We'll convert it to a single number through a vector length node. Promote this to a variable and name it Speed. And we can connect it to the previous getCharacter variable. Now we will check if the speed is greater than 0. If it is, we know the character is moving. This will help us transition from an idle pose to the blend space that we created earlier. Promote the red pin to a variable and call it isMoving. We can attach it up to the speed variable. Now we'll grab the character variable again, and this time search for a isFalling node. Once again, we will promote the red pin to a variable and name it isFalling. We can attach this up to the isMoving variable. This will come in use later when we add a jump to the character. Get the character variable again, this time searching for Get Actor Rotation. We will get a velocity node once again, dragging off the yellow pin and searching for a rotation from X vector. Now dragging off the Actor Rotation pin, get a delta node. This will connect it to the A part of the delta, while the rotation from X vector will be connected to the B part of the delta. Right-click on the outgoing pin and select Split Struct Pin. Now we will invert the results only on the Z-axis. This is a small calculation that gives us our direction. We can promote this pin to a variable and name it Direction. Now we can connect this to the isFalling node. Now we have used the event graph to set our information. Next up, we have the anim graph.
All right, to start off, we're going to transfer the input controls from the master to the player blueprint. The master is there to hold code that applies to all characters, players, NPCs, and enemies. Since NPCs and enemies do not need input-based controls, we're going to open the master up. Cut the code on the event graph with Control X and paste it to the player blueprint's event graph. You might need to click the blue text at the top to open the full graph. Compile and save. Now hit play to make sure everything is still working the same. Now, we're going to make some adjustments to how the character moves by giving the ability to strafe left and right. This couldn't be simpler. Click the top component in the window and in the details panel, search for YAW. Yaw. Check Use Controller, yaw rotation. We can hit play and right away we can strafe left to right. Holding both forward and left or right will move in a diagonal direction. Walking backwards, however, still has some setting up to do and will not look right just yet. So let's fix that now. A couple minor things. In Details panel, search for Orient Rotation to Movement and check this off. This is better used for enemies and NPCs, but not required for players with a strafe setup. We will also click on the character's movement component and change max walk speed to 400. Now we will need to create a few walk back animations, as we are missing those assets. Go to Unarmed Animation folder. Right-click on the AS walk back and duplicate it, adding _left to the file name. Repeat this once more and rename it with _right. We can select them both and hit enter so they both open in different windows. I'll slide them into the tabs at the top. On walk back left, we will scroll down to import rotation. Change the Z value from 0 to 45. Then at the top, click re-import animation. Do this again for walk back right, but change it from 0 to -45. Now we can open the animation blend space and drag and drop the walk back left at the -135 direction and 200 speed location. Make sure to adjust the numbers to be exact. Now repeat this on the other side for the walk back right. You can now do a quick save all. To get the back pedal to have reduced movement speed, we will add a tiny bit of code. Start by adding a variable. Name it Move Speed Back Penalty. Change the type from a bool to a float. Compile and give it a default value of 1. Now create a function. Name it fMoveSpeedBackPenalty set. On the right-hand side, click the plus to add a variable. Name it y. We will drag out the y pin and use the equal sign to enter for a greater equal. Drag off red pin and search for branch. Connect this function start, then drag out movement speed variable to the graph and select set. Connect this to the true branch and set the value of 1. Copy and paste the variable and connect it to the false branch. Set the value to 0.25. On the movement input selection, we will make a bit of room by sliding the current code to the right. In this new space, we will drag out our function and connect the execution pins and the matching Y pins. Now drag out the movement speed variable, this time choosing Git. Drag off the pin and search for multiply. Connect all of these to the move left-right graph. Through copy and paste, I now repeat this on the other side forward and backward movement. Now we can hit play and our character has a backward movement speed penalty. One thing I noticed here is our character is not flush with the ground. Let's adjust that. Click on the mesh in the Components tab and change the Transform Z location from -89 to -93. There we go, much better, looking good. Our character now has 8 directional movement speeds with strafing. What? Time to code our dodge roll. First, we're going to set up a way for our player character blueprint to communicate with the animation blueprint. We will do this through a blueprint interface. In Mixamo folder, right-click, go to the blueprint category and create a blueprint interface. Name it interface_ABP_Mixamo_XBot. We can select both and hit enter to open them both up. On the animation blueprint, we will add the interface. We do this through class settings. Use the drop-down menu to search for ABP. Select our newly created interface and click Compile. You can see the interface selection. A default function appears. Back on the interface blueprint, we will rename this to interface_dodge. Click the plus sign on Inputs and label it Enabled. On the animation blueprint, we will right-click the interface dodge and select Implement Event. Now we can create a variable by right-clicking on Enabled and labeling it Dodge. This will let us use the variable in our animation blueprint. We will search the blend poses by bool node and hook up our Dodge variable. Now let's connect locomotion to the false pose and drag out our Dodge blend space for the true pose. Hook up direction to the top and set speed to 1. Once again, our character blueprint will send a message to the animation blueprint to turn the dodge animation on and off. Now we can open our player character blueprint. The first thing we need to implement is a new keybind. This is easy as it can be. At the top of the blueprint in the event Begin Play selection, we can use the magnifying glass to pop out our control mapping, IMC, default. In the mapping, we can click the magnifying glass again on the jump binding. We will use this as a base and duplicate it, renaming it to Dodge. For now, we can leave the default settings. Back in IMC default, we will add a mapping and select IA Dodge. Set the key to left shift. Back on our character blueprint graph, we can search for IA Dodge and select the enhanced action events. A dodge is simple. A movement speed increase into a particular direction for a short period of time. Our keybind will dodge immediately, and following a short timer, stop the dodge. Now let's start an event timer, dragging off the event pin for a custom event. Name it CE Dodge_off. The top selection will be to turn dodge on, while the event will be to turn the dodge off. We'll make a simple bool variable to track this. Name it Dodge and drag out to set at the top and bottom. On the top side, click the checkbox. Set the timer to 0.5 seconds. Now we need to change our movement speed. So we will drag out the character movement and search for Set Max Walk Speed. The top side we will set to 1,200, while the bottom will be our default movement speed to 400. Now we need to send a message to Animation Blueprints to turn on the dodge animation. We do this by getting the mesh component, dragging off the mesh pin, and searching for Get Anim Instance. The anim instance is an animation blueprint. Now we can use our interface from earlier to communicate. Drag off the anim instance pin and search for Interface Dodge. On the top side, set it to true, and on the bottom side, set it to false. Here we're going to make a few adjustments for some polish on that dodge roll and the movement feel. Select the character movement component and set the braking deceleration walking to 15,000. This makes you stop immediately when you let go of your controls. Now let's compile, save, and give a quick test to our dodge. It's getting there. Next up is polishing it off.
We're going to quickly implement a jump using Mixamo animations. Let's head back to Mixamo. The first animation we're going to search for is Fall Idle. We're going to select this one here with the arm spread at an angle. Once again, make sure Without Skin is selected. We will put it in the mobility folder and name it AS Fall Idle. Now search for Jump Up. We will download Jumping Up, which looks like a mannequin flapping his arms like a bird trying to fly. Let's name this AS Jump Up. The last animation to search for is Falling to Landing. Before we download this, Mixamo lets you cut frames off the animation. We don't want the animation to start in the air. We only need the impact of hitting the ground. Using the bottom trim bar, move the left side handle to the right, cutting off 22 frames. We can now download this and name it AS Jump Land. Back in Unreal Engine, we will go to our mobility folder and import all three animations using the SK Mixamo Xbox skeleton. Let's open up our animation blueprint. We will go back to our animation graph, which is on the left. Double-click into the locomotion state, and here's where we'll add our jump. Right-click and choose New State 3 times. The first one will be Jump, then the second one will be Fall, and the third one will be Land. Let's connect these together to form a bit of a circle. We can double-click into each of these and add the respective animation. In Jump, we will drag out AS Jump Up and connect it. In Fall, we will drag out Fall Idle and we'll connect that. And lastly, we'll drag out our Jump Land and connect it. As we previously did, we now have to set the rules to allow the animations to flow to each other. For the first rule, it's simple. Drag out the isFalling variable and connect it. IsFalling is activated once you hit Jump or press the spacebar. To transition from the Jump Up animation into the Falling Idle animation, we will check to see if the Jump Up animation is almost complete. We'll right-click on the graph and search for the Jump Up animation. We will choose the Time Remaining Ratio node. We'll drag off the green pin and look for a Less or Equal node. And we will set this to 0.2. Once again, this means when the Jump Up animation is almost complete, it will transition into the Fall Idle animation. To transition from the Fall animation to the Landing animation, we use the Not Boolean node. This can be a bit confusing, but it just means when the isFalling variable changes to something it is not, then the animation can transition. Essentially, when you jump, isFalling will turn true, but when you land, isFalling will turn to false, and that will allow the transition. Finally, Just like the jump up animation, we will check if the landing animation is almost complete. If it is, then move back into the locomotion. Search for jump land remaining and choose ratio. In this case, we're going to set a value of 0.5. We only want a few animation frames of the landing impact. It will be a bit subtle, but it will feel smooth. As a last little tweak, our animation is a touch slow. Let's open up the jump land animation and change the rate scale to 2.5. And now our jump is complete. We can now run around and do some jump dodges for victory. Parkour. We're going to set up a series of blend spaces. This will allow us to have different game design options in the future. We will repeat the unarmed blend space setup for different animation poses. In this case, we're going to set up the one-handed weapon and shield blend space. In our animation folder, let's create a shield folder. Then we can download the shield animations from Mixamo. We will start our search with shield run. Note that each animation must have in place checked, and always make sure that without skin is selected. As we are saving the animation file, we need to create a new folder and label it shield. Even though Mixamo has these labeled as sword and shield, we're going to simplify it to just shield. This is because you could use any one-handed weapon with this animation, such as a mace, axe, wand, scepter, anything you can think of will still work with the shield animations. Just like with the unarmed blend space, we'll use the same naming convention. We can label this asset to AS shield run forward. Now we will repeat these steps for the right run strafe and name it as AS shield run right. And again for the shield run left. Now we can search for shield walk. From here, we can download the walk forward animation, walk back animation, walk left, walk right. Now back to Unreal Engine. In our shield folder, we can import all of our animations. Just like with the unarmed animation blend space, we have a few animations missing to adjust. We will duplicate the run forward animation 2 times, label it as AS run forward left and AS run forward right. We'll do the same thing for walk forward, create a walk forward right and a walk forward left. And finally, for walk back, create a walk back left and a walk back right. Now we're going to open up our animation assets and change the import rotation to turn them. For the run forward left animation, we can change the Z import rotation to -45, then click re-import. For the run forward right, we will change the import rotation to 45 and re-import. On walk back left, we'll change the Z import rotation to 45, and then walk back right, change it to -45. And finally, the walk forward left change to -45, and the walk forward right change to 45. Don't forget for all of these animations to re-import them. We can make sure we click Save All, and now we can create our blend space. To save time, we can go to our unarmed folder, drag and drop the unarmed blend space into our shield folder. Make sure to click Copy. We will rename it to BS_shield. Now we can open it up. Make sure Snap to Grid is selected on both horizontal and vertical axis. Then we can delete all the nodes in place. In the asset browser, we can search for forward shield. You can rearrange the view to see the full names. We're going to mimic the same thing as the unarmed blend space. All of the run animations will be at 400 speed. Run forward goes at 0 direction, forward left at -45, forward right at 45. All of the walk animations will go at 200 speed. Walk forward will be at 0 direction, walk forward left at -45, and walk forward right at 45. Now we can search for back shield. Place walk back at both sides at 400 and 200 speed. Back left at -135, and back right at 135. We'll repeat this for 400 speed as well. Now we can change our search to right shield, place run right at 90 direction and 400 speed, and then walk right at 90 direction and 200 speed. And we'll repeat this for the left side at -90 direction. Our shield blend space is now ready to go. We can open up our animation blueprint and head down to the current unarmed blend space in locomotion. Drag out the shield blend space and copy the direction and speed variables to connect them. Connect the shield blend space to the results to make it active. And now we can test our blend space. We're ready to swat at foes and block their attacks.
Alright, so this time we're going to set up our two-handed blend space. In Mixamo, this is the greatsword set of animations. For our folder, we will label it two-handed, since you can use these animations for axes, swords, maces, or whatever else two-handed you want to pick up. In Mixamo, we will search for the greatsword run. Make sure In Place is checked when downloading the forward run without skin. Alright, let's make a new folder in your animation directory for two-handed. Label this file as AS two-handed run forward. Now again, with strafe right run and strafe left run. We will download the walk forward, walk back, strafe walk right, strafe walk left. Naming them the same conventions as before. AS two-handed walk forward, AS two-handed walk back, AS two-handed walk right, and finally AS two-handed walk left. Back in Unreal, we can import all of these animations and duplicate the forward run 2 times for run forward left and run forward right. Now repeat for forward walk left, forward walk right. Also duplicate walk back left, and walk back right. Now on the same import rotations we've seen before. Run forward left will be -45. Run forward right will be +45. Walk back left will be +45. Walk back right will be -45. Walk forward left will be -45. And walk forward right will be +45. I dare you to say that 10 times in a row. What? Now let's hit a quick save all, and we all can copy a previous blend space to the two-handed folder. Let's rename this to BS_two-handed. Open it up and we can delete the current nodes in place. Search for run two-handed. Run forward goes into the 0 direction and 400 speed. Double check that snap to the grid is on for both directions and speed. Run forward left at -45 direction and 400 speed. Run forward right at +45 direction. Run left in the -90 direction and 400 speed. Run right in +90 direction and 400 speed. Now search for walk two-handed. Place walk back at both sides at 400 and 200 speed. Back left at -135 direction for both 400 and 200 speed. Back right at +135 direction for both 400 and 200 speed. Walk forward will go to 0 direction and 200 speed. Walk forward left at -45 direction and 200 speed. Walk forward right at +45 direction and 200 speed. Walk left at -90 direction and 200 speed. Walk right at 90 direction and 200 speed. Woo! We did it! Now our two-handed blend space is ready to go. What? All right, good job. Now let's open up our animation blueprint and head down to the current blend space and locomotion. All right, so drag out the two-handed blend space and copy the direction and speed variables to connect them. Connect the two-handed blend space to results to make it active. Now we can test our blend space. And we're ready to smash some foes with a big two-handed weapon. Yeah!
Now it's time to set up the rifle blend space. For our folder, we will label it Rifle. In Mixamo, we can set our search for Run Rifle. Unlike the other blend spaces, Mixamo has all the necessary animations for rifle movement. We won't have to make copies for the forward left, forward right, back left, and back right animations. As always, make sure In Place is checked, and we will download the forward run without a skin. As a note for rifle movement, make sure the hands are in an upward position holding the gun high in an aim position. As we download this, we'll create a new folder and name it Rifle. We'll continue with our naming convention as before, labeling it AS_rifle_run_forward. Now we'll repeat this for rifle run left, rifle run right. As mentioned before, rifle does have the forward left and forward right animations. We can download those now and label them appropriately. Now we'll change our Mixamo search for Walk Rifle. And we'll follow through with the same process as before. Walk forward, walk left, walk right, walk backward, walk backward left, walk backward right, walk forward left, and walk forward right. Then moving back into Unreal Engine, we can import all of our animations into the rifle folder. Make sure to choose the Mixamo Xbox skeleton and click Import All. We can now drag and drop our shield blend space to the rifle folder, making sure to click Copy. We'll of course rename it to BS_rifle. We can open it up and delete the current nodes in place. Now in the bottom right, we'll search for Rifle Run. All of our run animations will go at the very top at 400 speed. Run forward at 0, run forward left at -45, run forward right at +45, run left at -90, and run right at +90. From here we can change our search to Rifle Walk. Walk back goes on both sides at 200 and 400 speed. Back left at -135 for 200 and 400 speed. And the opposite, +135 for back right. Walk forward at 200 speed in 0 direction, forward left at -45, and forward right at 45. And finally, walk left at -90, and walk right at +90. Our rifle blend space is now set up and ready to go. We'll now test it out by going to the animation blueprint and bringing out the blend space onto the graph. We will copy once again the direction and speed and hook it up to results. We're now ready to go pew pew pew.
All right, this time we're going to set up bow blend space. Make a folder and label it bow. In Mixamo, we will search for bow run, making sure In Place is checked, and we will download the standing run forward without skins. Make a new folder in your animation directory for bow. Label this file AS_bow_run_forward. Now again with strafe left run. Repeat this for strafe right run. Now change our Mixamo search for bow walk. We will download this standing walk back, standing walk right, standing walk left, standing walk forward. Naming them with the same conventions as before. Back in Unreal, we can import all of these animations into our bow folder. And duplicate the forward run 2 times for forward run left and run forward right. Repeat for the forward walk and duplicate for walk forward left and walk forward right. And finally, our walk back. Duplicate for walk back left and walk back right. Now on the same import rotations we've seen before. Run forward left will be -45. Run forward right will be +45. Walk back left will be +45. Walk back right will be -45. Walk forward left will be -45. Walk forward right will be +45. And let's hit a quick save, all, and we can copy a previous blend space for the bow folder. Rename this to BS_bow. Open it up and we can delete the current nodes in place. Search for run bow. Run forward goes into 0 direction at 400 speed. Run forward left at -45 direction and 400 speed. Run forward right at +45 direction and 400 speed. Run left in the -90 direction and 400 speed. Run right in +90 direction and 400 speed. Now let's search for walk bow. Place walk back at both sides at 400 and 200 speed. Back left at -135 direction for both 400 and 200 speed. Back right at +135 direction for both 400 and 200 speed. Walk forward will go to 0 direction and 200 speed, or walk forward left at -45 direction and 200 speed. Walk forward right at +45 direction and 200 speed. Walk left at -90 direction and 200 speed. And lastly, walk right at +90 direction and 200 speed. Now our bow blend space is ready to go! So now let's open up our animation blueprint and head down to the current blend space in locomotion. Drag out the bow blend space and copy the direction and speed variables to connect them. Now let's connect the bow blend space to results to make it active. And now we can test our blend space. And I think we're ready to become a trained archer. What do you think?
And our final blend space we'll be setting up is the stealth blend space. This isn't necessarily an exact thing that's available on Mixamo, but we're going to piece a few things together in order to get it to work. Let's make a new folder and label it stealth. In Mixamo, we will search for sneak. Note that for the stealth blend space, we will not need any run animations. We will choose the walk forward animation that has the arms up with the elbows elevated outwards. Make sure in place is checked, and we will download this without the skin. Once again, we'll create a new directory, label it stealth. We can label this AS stealth walk forward. For the strafing left and right, we will only need to download one animation, which is crouched sneaking right. We are going to download this animation again. This time, we're going to make sure mirror is checked. Now we can import these 3 animations into Unreal Engine in our stealth folder. We will have to make duplicate copies to get this to work properly. We will duplicate the walk forward for the walk forward left and walk forward right. Now we're going to duplicate walk forward again, but this one is going to be for walk backwards. Once this has been copied and you've renamed it, we'll open it up and change the play rate scale to -1. When walking backwards, the forward animation will play in reverse, giving the appearance of walking backwards. We can also duplicate walk backwards now for the walk back left and walk back right animations. Now we can make our adjustments for import rotations. Let's open up back left, back right, forward left, and forward right. For walk back left on the import Z rotation, we are going to set it to 45. For walk back right, we'll set it to -45. For forward left, we'll set it to -45. And then finally, forward right, we'll set it to 45 degrees. Make sure you are re-importing each one of these animations once you've made your rotation changes. Let's make a quick save and copy over our previous blend space we've created to our stealth folder. We'll rename it to BS_stealth. We'll open it up and delete all the current nodes in the graph. In the bottom right, we can search for stealth. Now note, for the stealth blend space, we're going to place these at both the 200 and 400 walk speed sections. Walk forward at 0, forward left at -45, and forward right at +45. Walk left at -90, and walk right at +90. Walk back on both sides of the graph. Back left at -135, and back right at +135. We have one more change to make. On the top line of the graph, at 400 speed, we will right-click each node and set the rate scale to 1.5. Eventually, our character will only ever stealth at 200 speed. But there will eventually be power-ups and speed boosts that will increase your speed to move faster. By increasing the rate scale, when a player does receive a speed boost, it will give a sense of sprinting while stealthing. Finally, to test out our blend space, we'll pop back into the animation blueprint, drag out the stealth blend space, and hook it up with the direction and speed into the results. Now we can hit play and start lurking in the shadows.
Now we're going to create a basic system to change our blend space through gameplay. We will start with enumeration. In our Coursera folder, create a enumeration folder. Right-click and go to Blueprint category and choose Enumeration. Name this E_animation_stance, then open the enum. We will click Add Enumerator at the top 6 times, one for each animation blend space. Make sure first option is unarmed. From there, we can add shield, two-handed, rifle, bow, and stealth. Let's open up all of our assets we need to work out of it. Open the player character, the Mixamo animation blueprint, and the animation blueprint interface. In the player character blueprint, add a new variable called animation_stance. Change the variable type to an enumeration we just created, E_animation_stance. Duplicate the variable and name it animation_stance_options. Change the variable to an array. Click Compile and Save so we can change the default options to the array on the bottom right. And add 6 options and select them in the same order as the enumeration. Let's set up the temporary keybind to swap animation stances. Right-click on the graph and search for one key to find the keyboard event for the one button. Drag out our animation stance options array, drag off the pin and search for Get. Then promote the green index pin to a new variable. Label this to animation underscore stance underscore current. Drag out the animation stance variable and choose set, hooking it up to get on the array. Get the animation stance current variable, drag it off the green pin, and search for increments and connect it. Now with animation stance current variable, every time we push the 1 button, the integer will increase and choose the different stance from the array. But now we have to reset the integer if it goes too high. Using the greater than or equal node, we will check if this has reached the last index in the array. Attach it to the branch. And if it's true, we will reset it to -1. If the player presses the button when it is at -1, it will increase to 0 and use the first index of the array, which is unarmed. Now, while we have mostly finished our code for our character blueprint, we need to communicate this to the animation blueprint itself. To do this, we need to add another function to our interface. Click Add and label this function interface underscore animation underscore stance. Add an input and change the type to an enumeration we created earlier, E underscore animation underscore stance. Let's label this animation underscore stance and make sure to compile the interface. Back in our animation blueprint, make sure to compile again and right-click on the interface animation stance and choose Implement Event. It will now pop us to where we added our dodge. Right-click on the pin and promote to variable. We will just adjust the name to have an underscore in it. Now we can go to Animation Graph where we have laid out all of our blend spaces. Drag out the animation underscore stance variable to the graph. We will use blend by enum node to swap out blend space based on what our animation stance is. Search for blend animation stance and select it. You'll notice some of the options are missing. We can right-click the node and add each option. Let me note you do not need to add unarmed as a default pose. It can be used for the first option. On the blend node, add shield, two-handed, rifle, bow, and stealth. Quite simple. Connect the corresponding blend space to each node. As mentioned before, add the unarmed blend space to the default pose. To finish this off, we can now go to our character blueprint and add the interface message we need to send to our animation blueprint. We can now copy and paste the mesh and get anim instance nodes. If you remembered, this is the same as our dodge blend space. And we will drag off the animation instance pin and search for interface animation stance message. Connect it and add our animation stance variable to the input. Now by pressing 1, we can change our animation stance and cycle through each one. Unarmed, shield, two-handed, rifle, bow, and stealth.
Now that we have a way to swap our animation stance, we're going to add idle poses and blend them just like the blend spaces from before. We'll start off by downloading some idle animations from Mixamo. We'll download the shield idle animation, making sure that without skin is selected. When you download each idle animation, make sure you save it to its respective folder. We'll name this AS Shield Idle. And we'll repeat this process for the other animation stances we've created. The Greatsword Idle animation, the Rifle Idle animation, and make sure that the arms are up in an aiming position. The Bow Idle animation, In this case, we want the arms downwards, not in an aiming position. For these final stealth blend space, we're going to look for the male crouch pose. We're going to select this one where he has one hand touching the ground in almost a running start position. Now we can import each of these to the respective folders in the Unreal Engine. We'll jump back into our animation blueprint. We'll go down to the locomotion state that has all of our blend spaces. We can copy the blend poses node and bring it over to our idle state. We'll place the blend here. In the bottom right, we'll search for idle and pull out all of our idle poses. The base idle will remain at the default pose. Then we can hook up each respective idle pose to the corresponding node. As a final check, we want to click on each idle pose, scroll down on the right, and make sure loop animation is on. Now we are ready to go. Every time we hit one, our idle pose will change. For me, I particularly love to sneak around.
We are going to download a few attack animations for our different stances. We will keep this pretty basic for now. We can start our Mixamo search with shield attack. We want our sword and shield slash that has the feet planted in place that don't move much. We can name this AS Shield Attack 01. We will now search for shield block. Now let's download sword and shield block idle. Name AS Shield Idle Block. Next search is Great Sword Attack. Download the Great Sword slash where the feet are planted in place. This one will be named AS Two-Handed Attack 01. Now search for Great Sword Block. Download the Great Sword blocking animation. Name it AS Two-Handed Idle Block. Now search for Rifle Shoot and download the firing rifle animation. Name it AS Rifle Shoot. Changing our search to bow recoil. We will download the standing aim recall animation. Now let's name this AS Bow Attack 01. Our final attack is for stealth. The only attack this will have is a stab. Let's change our Mixamo search to stab. We will download the stabbing animation and put this to our stealth folder and name it AS Stealth Attack 01. From here, we can import each animation in their respective folders. Once complete, hit that Save All button, and boom, we're ready to go.
Now we will implement a basic keybind for attack and block. In our character blueprint, on the Event Begin Play section, let's use the magnifying glass to jump to our IMC default folder. In the Actions folder, we can duplicate the IA Dodge file and rename it to IA Attack 01. Duplicate the file again and rename it to IA block. Open the IMC default file and add the IA attack and IA block to the list. For attack, make the keybind left mouse button, and for block, make the keybind right mouse button. Back on the character blueprint, we can search for IA attack and IA block. We can add these events to the graph. Drag out our animation stance variable to the graph, and off the pin, search for a switch node. We can now change the functionality based on our animation stance. We will drag out our mesh component and off its pin, search for play montage. And now we have to create animation montages for each of our attacks. If we click on our animations folder, we can search for attack. Select all of them and right-click. Go to the Create category and select Create Anim Montage. And we'll repeat this for the shoot animation for the rifle blend space. For the shield section, we can add the shield attack montage. Then we can repeat this for each animation stance and their respective attack montage. Our last thing to do is in the animation blueprint on the anim graph. We can slide the output pose to the right to make room. Right-click on the graph and search for default slot. We can add this to the graph and connect it on both sides. You'll notice our attacks are working based on the animation stance we have active, but currently, the entire animation is played as we move around. The next level of polish is a blend per bow node. This will play the montage on the top half of the character and keep the locomotion on the bottom half of the character. Either way, we now have an entourage of attacks for any situation.
Here we are going to implement a way to have two animations active at the same time. If we walk around and use our attack animation, the whole animation plays and looks like we are gliding in place. We will implement some logic to have the top half and the body play attack animation while the bottom half of the body plays the locomotion blend space. Let's open our animation blueprint. First up, we're going to create a cache for our locomotion state machine. This is kind of like saving it to a variable. Drag off the locomotion pin and search for cache. Select New Save Cached Pose. Rename this to cache_locomotion. We will rearrange the default slot before the dodge. This will make sure animation montages don't play during the dodge roll. We can search for each locomotion and select Use Cached Pose, cache_locomotion. Here is where we search for a layer blend per bone. Connect this to the false pose of the dodge roll node. If we select the layer blend per bone node, there are options to change on the right-hand side. Expand the layer setup and add a branch filter. Here we need to make sure we get the exact bone name we need. In this case, we want the lowest spline bone. Using the shortcut links at the top, click on the Skeleton tab. We can see it labeled spline. We can select the name in the top right and copy it. Use the quick links to pop back to our animation blueprint and paste in the bone name to the options. Now we can connect the default slot to the Blend Pose 0 pin. And copy and paste the cache locomotion for the base pose. Now we can walk around and use attack animations. The top and bottom selections of the character are split. It might not be perfect, but it's good enough step for now. The next change to make is that we want to play the full animation if we are standing still. We can use the isMoving variable and utilize the blend by bool node. Once again, we'll place this before the dodge roll to ensure this never occurs during the dodge roll. Now we can save the default slot to the cache and name it cache_default slot. Now dragging off the isMotion variable, search for blend by bool. Search for cache default slot and replace it back to the layered blend per bone. Connect the layer bone node to the true path of the isMoving node. On the false path, we will use the cache default slot. So now if we test this, standing still will use the full animation. While moving, it will use the half blend split. And that is the blend per bone setup. All of these small changes add to the animation polish of your game, looking smooth and pretty.
We are going to implement our block animations. In our animation folder, search for block. Just like with the attack animations, we'll select them both, right-click, and create an animation montage. In this case, we'll open both animation montages up and make a tiny adjustment. We will select the green bar at the bottom and change the loop count to 99. This will set it to the max it can go. In this case, it's 32. Now we can go back to our character blueprint. We will copy the animation stance, switch, and 2 play montage nodes from our attack keybind. Paste them down by our block keybind. Instead of connecting these to the triggered pin, we'll connect it to the started pin. Change each of these to the shield block montage and two-handed block montage. On the two-handed section, we'll add a reroute node and connect all the non-shield pins. This will just give each pose a block option. Let's open up our block keybind. Click on the content folder and search for block IA and open our keybind file. Under triggers, click the plus to add another entry. Use the drop-down menu to set this to released. Back on the character blueprint. On our block keybind, you might have to click the down arrow to expand it. We can drag off the completed pin. This is where the player releases their button. Search for the stop anim montage. This will stop the block animation when we release the button. We're ready to take on the mightiest of foes and block all their attacks. It's time to implement an air dash. First up, we'll download a pose from Mixamo. Search for dash pose. Download the female locomotion pose. Make sure without skin is selected. Save it to the mobility directory and name it AS air dash forward. Back in Unreal, we can import the animation to our mobility folder. Once imported, right-click on it and create an animation montage. Just like Block, we will open it up and set the loops to 99. Then we can close it out. Now we can open our character blueprint. We're going to implement our air dash into our dodge button. If the character is on the ground, they will dodge, but if they're in the air, they will do an air dash. We can slide our dodge keybind and the dodge branch to the left. Right-click on the graph and search for is falling. Let's create a branch off this node. If it is false, it will continue to execute a dodge roll. Let's move over to the end of our dodge roll and copy the event timer for velocity. Copy the timer, the custom event, and the add movement input nodes. Paste it back by the isFalling branch. Connect it to the true pin on the branch. Rename the custom event to CE air-_velocity. Delete the dodge velocity variable and search for get actor rotation. Drag off the pin and search for get forward vector. This will make sure the air dash always moves in a forward direction. For both nodes, right-click on the vector and select Split Struct Pin. This will separate the X, Y, and Z. We only want this air dash to move along the X and Y, and not the Z. On the timer node, right-click on the return value and promote it to a variable. We can name this timer air-velocity. Now create another event timer and custom event. Rename the custom event to CE air-_off. Set the event timer to 0.75 and make sure looping is off. Now connect it to the current line of code. Create a new bool variable and name it air dash. The top section is for when air dash is on, while the bottom section is for when air dash is off. Set the air dash variable to true on the top section and false on the bottom section. Right-click on the graph and search for set movement mode. On the top side, we will set it to flying, and on the bottom side, we will set it to walking. Make sure they are connected to the character movement component. We will also select our character movement component on the left side, and in the details panel on the right, search for fly. Enable the checkbox for can fly. Set the max fly speed to 2000, and the braking deceleration flying to 15,000. Moving on with our code, we can copy the mesh and play montage node from our attack animations and paste it at the top. Change the animation to the air dash montage. On the bottom side, we will add a stop anim montage node. We will pause here for one moment and head over to our air dash montage. We need to create a new slot for this montage. Where it says default group, click on the drop-down labeled slot. Select Slot Manager. Click the Add Slot button and name it Full Body. On the drop-down menu, before where it says default group, change it to the Full Body slot. You can use the quick links to move into our animation blueprint. We can copy the default slot node and paste it after the dodge roll blend. Connect it to the current logic. And then in the top right, change the slot name to Full Body. And now we'll switch back to a character blueprint. At the very start of the air dash off custom event, add a clear and invalidate timer node for the air dash timer. Our air dash is almost fully implemented. When air dash turns off, we want movement to stop. Add a stop movement immediately node after stop and a montage. If we collide with an object during an air dash, we want to turn off our air dash. Select the capsule component and get the add-on component hit event. We will pull out the air dash bool and create a branch. If we're dashing, we will execute the CE air dash off custom event. If we're not dashing, we will do nothing. Now our dash is gliding smooth as can be. For our final change, let's add a double jump. In Unreal Engine, there's actually a built-in double jump system. Select the character component, and in the Details panel, search for Jump. At the very bottom, set the jump max count to 2. We now have a dodge roll, air dash, and double jump ready to parkour around the level. I challenge you to climb to the highest peak of the level.
We are going to quickly add a few comments throughout our code as a review, and to keep our character blueprint nice and organized. Let's open the character blueprint. Let's start by selecting all of our code and dragging it down to give some nice space. For our first comment above on the component, hit event and we will comment this. If we are air dashing and hit something, stop the air dash. Above the dodge keybind and at the dodge branch, we will comment, prevent the player from dodging if they are currently in a dodge. Above is a falling node we will add. Change the dodge functionality if the player is in the air. If the player is in the air, air dash. If the player is on the ground, dodge roll. Above the air dash event timer, add velocity in the forward direction. Over the next event timer, comment, initiate a timer to turn off the air dash. Followed by turn on the air dash over the air dash variable. Then set the movement mode to flying and play the animation montage for air dash. We can select this top row of code and raise it up a bit. Above the air dash off custom event, turn off the air dash velocity timer and turn air dash off. Followed by set the movement mode to walking. And stop the animation montage, ending with stop the character movement immediately. We can select the next block of code and move it down more. On the dodge selection of code above the event timer, timer to turn dodge off. We can expand the previous dodge comment, turn dodge on. Move our past dodge off comment back over to the proper variable and change it to turn dodge off. Over our bottom selection for walk speed, add a comment with reset walk speed to default 400. On the top side, increase walk speed to 1,200. On the top side for interface dodge, add set animation blueprint dodge to enabled. And on the bottom side for the interface dodge, set the animation blueprint dodge to disabled. Here we can comment disable input from the player and copy it to the bottom for enabled input from the player. Above the clear invalidate node, add turn off dodge velocity timer. Over the velocity length branch, we will comment change the velocity source based on if the character is moving in a direction or standing still. At the very end, comment timer for dodge velocity. Now let's rearrange our code downwards once more. Above are 1 keybind. Keybind to change animation blend spaces. Above are attack keybind. Keybind for attack animation montages. And finally, over our block keybind, keybind for block animation montages. And there we have it. We have completed our steps for our animation kit for this course. Good job, everyone. Woo-woo! Congratulations on making it through the animation module. So let's get to the review on what we've learned. We've learned the core animation technical features within Unreal Engine, animation blueprints with the event graph and animation graph, animation sequence and a single animation asset created in Blender or using Unreal Engine's control rig, animation notify that can indicate code at a specific time in an animation asset, animation montage, a file to compile sequences together to use for the player's actions, like attacks and blocks. Animation blend spaces to smoothly transition animations based on a two-directional graph. Procedural animation uses math, physics, and code to power animations. Motion capture can dramatically benefit production with high-quality animations, but also has a high upfront cost. Mixamo is an incredibly useful resource for thousands of animations. We created a new project and implemented various blend spaces for future game design prototyping. We also implemented dodge roll, air dash, and double jump as core movement mechanics. Added polish to our animation through the blend per bone node, allowing the characters to play two animations at the same time. Firstly, take a deep breath and be proud. Each step you take gets you closer to bringing that theory graph you have always wondered about to life. It allows you to not only have it in your thoughts, but begin visualizing it, tinkering with it, and iterating to find that truly unique game design. So, good job. Welcome to the 3D model overview. In this module, we will cover how a 3D model is created, the beautiful characters and environment in a 3D game, the artwork that makes you feel immersed into a world you play. We will discover the inner works of a 3D model and how it's broken down. learn the industry standards, optimization techniques that let us play our games with smooth frame rates. Implement 3D models from the Unreal Engine Marketplace to use in our gameplay. Discover the workflow of a 3D model from scratch to implementation. By the end of this module, we will redesign the stylized Egypt level and transform it into a start of something new. So I'd have to say, let's get building. Optimizing 3D assets has been a never-ending push for game technology. Historically, games will have a triangle budget range for their game at any given time. As a player walks around the level, triangles should never exceed a specific amount of triangles based on the project's requirements. In-engine tools help developers diagnose how many triangles and draw calls are on the screen. Nanite has made incredible improvements on this front, allowing billions of triangles be rendered. However, Nanite is still only available for high-end PC hardware and the latest generation consoles for PlayStation and Xbox. For lower-powered systems such as phones, tablets, Nintendo, Switch, or older generation PCs, many of these optimization techniques are still required. So here, we'll discuss many of the common techniques used in today's games. Level of detail will automatically lower how many triangles a 3D model has based on its distance from the camera. The less triangles a 3D model has, the less resources the CPU or GPU needs to use in order to render it. Level of detail can be created in external 3D modeling programs for a controlled breakdown of a model, or generated automatically through the Unreal Engine. As a 3D model loses triangles, its shape will start to deform. The overall idea here is that the 3D model will be too far away for a player to notice the imperfections and reduced triangles. But as it gets closer to the camera, the quality level is increased until it is at fully intended triangle count. 3D models also have materials that apply textures and other visual appearance settings. Each material used in the 3D model will result in a draw call. On a quick note of materials, how complex a material is can also impact how performance-intensive it is to render. Instance static meshes, or hierarchical instance static meshes, are one method of lowering draw calls. You can have multiple instances of the same static mesh that will all use the same material. This will result in a single draw call for thousands of static mesh. From there, you're able to change the location and scale of the static mesh. Even Unreal Engine's foliage system utilizes this feature. There are additional ways to optimize character-based 3D models through Unreal Engine's features. If your character is broken down into several parts, the leader pose, copy pose, and the skeleton mesh merge all of their pros and cons on improving performance. The last optimization technique is through creating normal maps. On the left is a high poly version of this fox statue with 1 million triangles. On the right is a lower poly version of the fox statue, which only 1,000 triangles, which you can pretty clearly see some of the details that are very different, especially where there are indents or grooves. A normal map is a technical feature in 3D modeling programs to compare a high poly model with a low poly model. The result will create a normal map texture file. In this case, I'm showing what a process looks like in Blender. The normal map will change how light interacts with the 3D model, which adds many of the details of the high poly model without all those extra triangles. You might have noticed this already. The low poly model looks pretty detailed considered to the high poly that has over 900,000 more triangles than it. This is because of normal maps. If I open the low poly model material up and disable the normal map, it immediately loses a massive amount of detail. You can really see the benefits of a normal map and how much they help reduce triangles so your game can run on a lower end hardware. Now, the downside to normal maps is that they do take time to create. If changes are made to the 3D model, then a normal map will have to be regenerated. This is another reason why Nanite is so powerful and a big game changer for graphics. It removes the need for both level of detail and normal maps to be needed. Not only does Nanite enable highly detailed models, but it also can significantly improve an artist's workflow during development. 3D modeling optimization is a topic that will consistently change over time. Keep your eye out in the future for new technologies that empower 3D artists.
We're going to get some weapons for our animation poses. In the marketplace, search for Infinity Blade weapons. Add these to your Corsair game project. In Unreal Engine, we can move these to the MP folder and fix redirectors. We can filter by level and open the overview map to take a look at all the weapons. There are some pretty funny ones, such as a bubble wand, chicken, and lollipop. You will be able to pick out a few of these to use on your character. For now, pick a single weapon to use for the weapon and shield setup. I decided to use the dragon sword. We can go back to our stylized Egypt level. If we look at the weapons in the Infinity Blade folder, we will see that the weapons are skeletal mesh. So make sure our main hand weapon is a skeletal mesh. Let's open our character blueprint. We can click the magnifying glass on our skeletal mesh to jump to our character folder. We need to open the skeleton. Here we have to add sockets to the character. These sockets will allow us to attach the weapons and rotate them into place properly. On the left forearm, right-click and select Add Socket. We will name it S_shield and move it slightly to where our shield will be held. In the top right window, you can set the exact location and rotation of the socket. Now we can repeat this for the right hand. Name it S_right hand item. Move it in place to be roughly in the palm of the hand. Back on our character blueprint, from the component list, we will add a skeletal mesh and make sure it is attached to the mesh. Name it right hand item. Now we will add a static mesh for the shield. Again, making sure it is attached to the mesh. On the right hand side of the details panel, we can click the magnifying glass on the parent socket and select the corresponding sockets we just created. Make sure the location and rotation are set to 0. On our right hand item, select your chosen Infinity Blade weapon. Here I'm choosing the dragon sword. You will notice the sword is not rotated properly. We can fix this on the character skeleton. First, let's preview our animation and set it to shield attack. It will start playing right away. Let's pause it and scroll to the beginning. On the right-hand item socket, right-click and choose your Add Preview asset, and search for your chosen Infinity Blade weapon. We can see the rotation and location problems here. In the Y rotation field, set it to 90 degrees and -180 on the Z rotation. This has mostly fixed the issue, but we can slightly move the socket into a better position for the hand and animation. Always check the animation and how the sword moves through. If it tries to slice through your character, you'll have to adjust the scale, location, and rotation to ensure it fits properly. Now back on our character, you can see it is properly being held. Infinity Blade weapons were mostly created the same, with the origin location for the weapons are all at the middle of the handle, where it should be held by the hand. The majority of the Infinity Blade weapons will now be held at the right spot. Some of them might be a bit extreme in size and are outliers. Depending how a 3D model is created, it can change how they equip to a character. This is an example of a good workflow from asset creation to importing into your game. If the origin of the weapon is at the same place for every weapon, it will always socket to the correct spot. If they were all different, it would start requiring annoying code to readjust location, rotation, and scale for every weapon in your game. Now it's time to get creative and resourceful, to improvise. We need a shield, but the Infinity Blade weapons do not have a shield. Let's take a look at the stylized Egypt stacked meshes. I've chosen the ornaments 02, 05, and 06 as shield options. Let's place them in the level to get an idea. Any of these are good enough to be a shield. I chose ornament 02, or the diamond shaped one. Let's set our shield component to this stacked mesh. Let's make sure to reset the location and rotation of the shield. Back on our skeleton, we can add a preview asset with the shield. And set up our preview animation to the shield attack. We'll pause it and bring it back to the first frame. Now we can rotate it into place. Note we don't need to change the scale here. We can do that part on our character. I make some rotation and location adjustments and preview the block animation to get a good look at it. This shield is certainly looking concrete, I'll tell you that. Back in the character blueprint, we can now play with the scale of the shield. Do what feels right to you. And there you have it. Our initial weapon and shield setup is complete. Now that we have our basic weapon set up, let's implement a system to change our weapons. In our character blueprint, let's start with a variable and name it sk_sword. We can set the variable type to skeletal mesh. Make sure to compile so we can set this to our chosen weapon, in my case, the dragon sword. Create another variable and name it to sm_shield. This time we'll change the variable to a static mesh. And we can copy our shield mesh to the variable. We'll now implement a function and place it into our animation swap code after the interface message. Click the plus sign for a new function and name it fWeaponSwap. Get the animation stance variable and off the pin, search for a switch node. In the component menu in the top left, drag out the right-hand item to the graph. Off its pin, search for Set Skeletal Mesh. We will start with the shield section off the switch node. Get our SK_sword variable and hook it up. Without selecting our SK_sword variable, we can copy and paste this for each section to connect them. At this current stage, our shield will not change, so it's simpler if we just show or hide it based on our current pose. In the component menu in the top left, drag out the shield to the graph, and off its pin search for Set Visibility. We can connect this to our shield section, and make sure new visibility is checked to true. We will copy and paste this node for the other sections, doing the opposite by checking them to false. For now, we will just point them all to this one node. Lastly, we have to set the default values for sword and shield. Select the shield and search in the details window for visibility. Uncheck it to false. On the right-hand item, clear the current entry. Let's test it. By pressing 1, it will cycle through animations, granting us our sword and shield when we are at that animation stance, while hiding it for the other stances. And now, we can move on to the next weapons. Let's get our adventurer's arsenal of weapons in order. Duplicate the SK sword variable and name it to SK_2H_sword and click compile. Change the two-hand sword to a weapon of your choice from the Infinity Blade weapon pack. I ended up choosing the Hero Sword 10. I've also spent a few moments to clean up our lines. Now we can just get the variable and hook it up to our two-handed section. With a quick test, and we can see our two-handed sword is working during our animation swap. Next up is the rifle. For the rifle, we will take the default rifle from the Unreal Engine first-person shooter template. As a reminder, we are using Unreal Engine 5.3.2 for this project. Let's launch the engine to create a basic FPS template project. Select Games and choose First Person. Keep the default settings, but uncheck Starter Content to save some hard drive space. Name the project First Person Template and click Create. The FB weapon folder has all of the assets we need for our rifle. Right-click on the FB weapon folder and choose Migrate. Click OK and find your Corsair game folder, which by default is in your Documents directory under Unreal Projects. Make sure to enter the Content folder before clicking Select Folder. We can close out of the First Person Template project. Back in Unreal, under our UE folder, let's create a folder called First Person Template. Move the FP weapon folder into the First Person Template folder and fix up redirectors. Back to our skeleton, a gun will have a different location and rotation than a held item like a sword. Right-click the right-hand bone and add another socket. This time name it S_gun. Change our preview animation to Rifle Idle. Right-click the right-hand item socket and select Remove All Attached Assets. This will remove the sword and shield. On the gun socket, add our new rifle from the First Person template. Let's take the time to rotate it, but remember it doesn't have to be perfect. Get the fingers roughly on the handle. Let's add another skeletal mesh, making sure it's attached to the mesh. Name it Gun. Attach it to the gun socket and set its skeletal mesh to the gun. Just like the shield, we can turn the visibility to be off by default. In our weapon swap function, we can copy and paste the shield visibility node to each line of code. Copy once more for our gun visibility, then repeat down each line of code again. Make sure to swap out the component from the shield to the gun. Only have the visibility checked on for the rifle in the animation stance. And now our rifle is ready to go. Let's get our epic bow going. On our skeleton, let's remove the preview assets from the gun. Set our preview animation to the bow attack. Since a bow is held in your left hand, we need another socket. Right-click on the left hand, add a socket, and name it S_bow. For the preview asset, add the Frost Giant Axe. Just like the shield, we are improvising with what we have. This axe has a handle that sticks out with a nice arc to a weapon as a whole. This will serve our purpose as a bow. We will move the position of the weapon differently so the hand holds the back part of the handle. Make sure to test the object from different angles to make sure it looks right. You can swap to other animations to test how it looks and feels. Back on our player character, add a skeletal mesh again, this time naming it Bow. Attach it to the bow socket, set its skeletal mesh to the frost giant axe, and finally, visibility default unchecked to false. Just like the gun and shield, we will add visibility nodes to each line of code that is connected to our bow component. Make sure visibility is true for the bow animation stance and false for all of the others. Now I gotta say, that's an epic bow. For our stealth pose, we are adding a dagger-like weapon. Duplicate the two-hand sword variable and name it sk_dagger. For this one, I'm using the Hero Sword 22. Get the dagger variable and connect it to the dagger section. And this completes our weapon implementation. We have a full kit of weapons to take on any boss. Bring them on. Our dagger will allow us to stealth around and backstab unsuspecting foes.
Unreal Engine has built-in 3D modeling tools. You can access them by changing the drop-down menu by selection mode and clicking Modeling Mode. There is a whole suite of 3D modeling tools you can use to create, modify, and edit existing 3D models. A standard method of 3D modeling workflows is by inserting edge loops and extruding selections outward. In this basic example, I create a robot-like model in a few simple clicks. On our examples for our shields, we can duplicate one, convert to a dynamic mesh, and make edits to change it. The changes to the dynamic mesh won't affect the current static mesh. From there, we could convert it back to its own static mesh as a new version. To learn more, we created a full course in UE5 using the 3D modeling tools. You create a boba shop. While the course takes place in UE5, the 3D modeling tools are the same as it is in Unreal Engine. This course reviews many of the 3D modeling features for beginners. You will create many unique shapes for a boba shop, add materials, and add some flavor with Fortnite creative assets. If you are further interested in Unreal Engine 3D modeling tools, I highly suggest you check it out. I'm going to show you an example of creating a 3D model from start to finish, where I create my adorable baked bun sign for our bakery shop. It all starts with a sketch, and I use Procreate for this, but you can use any other 2D program that you're most comfortable in, but Procreate is mine. So I ultimately knew I wanted to create a character based on a baked bun. I started to play with some different shapes and silhouettes for this character, and tied into that bakery theme, so I went with the big chef hat. From there, I knew I was on track with what I wanted, but it's still important to try other shapes and ideas for part of discovery process, because ultimately it's usually like your 20th sketch or 50th sketch that you really get something great. But for me, I felt like it was super appropriate and simplistic how I wanted it, and ultimately it was just so cute. So let's iterate them further. I tried to play around with different noses and smiles, big eyes versus dots or small eyes, and seeing how ears even look too. I knew I really wanted them to like hold something, kind of really pulling into that expression of baking and being excited to bake. So I decided to obviously pick tools, and what's not more perfect than a spoon and a whisk for a baker? But ultimately, I decided to go with B selection and added hands so they can really hold their little tools and give a good expression. For reference here, this is a great way to also pitch a rough design concept for a project or to other team members. Here, I really wanted to try the opposite to what I had, a big top chef hat with a small body or a big chunky body with a petite hat. Now I'm going to start to figure out my base colors and make sure I'm keeping my design simple and clean. Also making sure I'm keeping my values in mind. Values in the terms used to describe lightness or darkness of a color, hue, tint, or tone. Value is one of the 7 elements of art and is important because it's how we see and understand objects. So I start messing with hues and ideas for what colors and making sure that my lighting's intact. I love using lighting. It's a big part of my art, and I feel like it gives emotion and a lot of character. Now I'm kind of cleaning up my shapes, getting some backlighting. I really love to use lighting and polishing up those tools and just really tinkering up with the final details that I feel add a lot of character. I started by finding a few references for a pattern I wanted to make of a fantasy wood texture for my sign. And so here you see me making my own. And tips on that, if you want a very fantasy whimsical grain, you need to loosen up those shoulders and be loosey-goosey with those swooshes and swivels because it is not a game for wrists or just light armed work here. Lots of full motion. Now I wanted to touch up my text, making it feel more bread-like, having buns in all of the little kind of like circles of the B's and the A's, really trying to add that organic feel of them being little baguettes or buns or any baked goods, making them feel very doughy, which gives that organic feel. Now that our 2D assets are complete, let's start to put them into our Corsair game project. I made a 3D modeling folder and created a new basic level. This will make it much easier to work in different perspective modes available. I take all of the lighting components and slide them off diagonally to get them out of the way. Save the level, the 3D underscore modeling folder, and name it level underscore 3D underscore modeling. Here I imported my full sketch from before that has the full shape. For a quick fix, right-click the sketch, under Sprite Actions, select Apply Paper 2D Texture Settings. This is just a quick way to make the backgrounds transparent. From the menu bar at the top, I add a plane into the level. I reset the plane location to 0, 0, 0, the origin to the world. Now I apply the texture to the plane through the drag and drop. I rotate the plane so that the front is facing positive X direction or the red arrow. Using the perspective button in the top left, I'm able to view the object at different angles. This can dramatically help the workflow when in 3D modeling. You can also set the lighting to unlit to not have to worry about any shadows. Now I'm ready to start 3D modeling my baked bun sign. All right, let's get to 3D modeling. I use perspective mode and go to the modeling tools to create a basic box and place it into the world. I made sure to set it to a dynamic mesh while I work on it. I'm going to scale up my sketch so it's a bit easier to work with. Working at a larger scale can be a bit easier for selecting. We can always scale down later though. I hide the floor to get it out of my view and start to create the big shapes. By inserting an edge loop, I'm able to extrude out the side of this box to more of like an L shape. Because I'm looking for a low poly style design, I want it so there are crisp, hard edges. I'm really looking for that low poly type of look, which is those sharp edges. I start to insert a few edge loops and move around the vertices to get my desired shape. Because I have a more loose sketch here, always remember that your sketch can be just a guideline. You don't have to follow them to the T, and there's always room for interpretation to get that shape to look just right. Unfortunately, to have that eye, it really takes a lot of practice and repetition, so keep at it. Now that I have my silhouette, I realize that the sign is thick. Let's move this back some vertices forward to thin it out. For my final modeling steps, I selected the outside edges to use the bevel tool. It took a little tinkering and looking at a few different options before settling on a value of 2. Our model is complete, but you can tell with the grid texture there are some issues with the UV. But we can fix this by using the UV tool and the Project UV. set projection type to box, and keep other settings to default. Now we can do UV unwrap and click accept. Once your model is complete and the UVs are set up, you have a few choices. The first choice is to bring the model into a 3D painting program. There are quite a few on the market today, such as Blender, Clip Studio, or Procreate, wherever you can import a 3D model and paint it. And what not better than a quick drink? To me, a gluten-free bun and a glucan drink sounds like a good option to me. The other option is to use the base texture for your sign, like I did previously with my wood texture. Since we have its starter content and other assets imported, you can already try adding different materials to see how it looks just for fun. I know I had a blast designing both of these things, so they definitely needed to go together. So I end up importing my texture files and applying the Paper 2D texture settings to get them working quickly. I can drag the wood texture that I created right on the top of my sign to automatically create a material for it. If the wood is going in the wrong direction, you can use the modeling tool project UV and rotation to fix this. Now the decal actor is another tool you can use too. In a way, spray paint a texture on a surface. At the top bar, search for decal and add 1 to the scene. It will create an invisible box, which doesn't quite seem like it does anything at all at first, but bear with me. When you move it into place, it looks all blurred. This is because the spray paint-like effects come from the top of the decal spraying downwards to the bottom. Because of this, I had to rotate it towards the sign, then scale it down. Decals also require a specific setup for their material. I right-click my texture and create material. Opening it up, I click on the output and set the material domain to deferred decal. Then the blend mode to translucent and connect the opacity to the alpha channel of the texture. Now we can apply our material to our decal. I work through positioning the decal how I want it to look on both sides. I ended up repeating the decal material creation for the baked buns texture as well. Finally, to save my 3D model in the content browser, I convert it to a static mesh and name it sm_sign_001. There you have it, a beautiful baked bun sign ready to hang in excellence. Woo!
In preparation for our upcoming assignment, let's get our project some free asset packs. Head over to the Unreal Engine Marketplace. You'll be able to search for a few of these items, which are all permanently free. We will add the Fantastic Village pack, the Advanced Village pack, and the Low Poly Hand-Painted Environment. If you're running on a little bit lower end PC, sometimes it can be better to move these folders one at a time. Back in our project, we'll move the new folders to the MP folder. Click OK for any pop-up errors. When finished, we can fix up redirectors. If the new asset folder remains behind, you can go ahead and delete them. They still won't go away. Right-click and choose Show in Explorer. Go up one directory into the content folder. And now we can delete the folder that won't go away. Just make sure you delete the right one. You can see we have a huge selection of assets available to us now. Now we can get assets from the Learning tab from Unreal Engine Samples. In the Epic Games Launcher, click the Samples tab. Scroll down to the Crop Out Sample project. We can click Create Project, and we can keep the default name. And now we'll open up the Crop Out sample. We don't need to do much here. The first step is to admire the beautiful scene. But then, we can open the content browser and click on the content folder. We can set the search filters to the Niagara emitter, Niagara system, and static mesh. Then we can select them all and migrate these to our Corsair game project content folder. Now in our Corsair game, let's make a new folder in the UE folder and name it Crop Out Sample. Move the VFX, UI, MISC, Environment, Characters, Blueprint folders into the Crop Out Sample folder. You can see it gave us another big chunk of assets to use. And don't forget to fix those redirectors. And now onto the last sample pack we'll add, Stackobot. Follow the same process in the samples and download Stackobot. Once it finishes downloading, we can open it up. Once again, open the content folder and make sure Niagara emitter, system, and static mesh filters are enabled. Migrate them to your Corsair game project. You can see that these assets are very different from the other ones we've got. Now move the Stackobot folder to the UE folder and fix up redirectors once more. Now we have a great pool of assets to work with. At this stage, you can also add your own assets that you might have purchased from the Unreal Engine Marketplace. Another fantastic resource is thebasemesh.com, which has over 1,000 free 3D models to choose from. This is a really nice resource for quick prototyping. Now we have what we need to dive into our assignment. We always want to make sure we stay on top of our code comments. Let's head into our player character. Once you know your code is at a decent state of functionality, it's a good practice to comment your code. For this module, we don't have too much to do here. On top of our function, we can comment. Change the weapon scale to mesh and visibility of gun, bow, and shield, based on the animation stance variable. Now let's click into our function. First, let's clean up the lines and make space for the comments. Use reroute nodes, as you need to, for straight lines that create a clear path. This makes your logic easier to understand for yourself and others you might be working with. Comment each line with the respective stance appearance. Unarmed appearance. Weapon and shield appearance. Two-handed appearance. Rifle appearance. Bow appearance. And finally, stealth appearance. That's it. We're up to date with our code comments.
Congratulations on completing this module. Let's review what we've learned. We've learned how 3D models break down into triangles that are sometimes seen as quads. Discovered how textures and materials are attached to each triangle through UV mapping. Explored various optimization techniques used for 3D models that help us obtain smooth frame rates. Some examples are level of detail, material complexity, reducing draw calls with instance static meshes, and normal maps. We integrated infinity blade weapons for our animation stances, found educational resources for the Unreal Engine 3D modeling tools, a UE5 Boba Shop course, walked through 3D modeling process from concept to implementation, set up our project with a myriad of 3D assets from Unreal Engine Marketplace, learning examples, and thebasemesh.com. We started a redesign on the stylized Egypt level, a journey to begin theory crafting ideas for future game design prototypes. You can now see the start of your design project transforming into the vast oceans of exploration. And as you can see, the adventure is truly in the power of your hands. Your next assignment will be to use the 3D models we've imported to change the current ancient Egypt level. Having a core focus on specific sections of the level while thinking about minor changes throughout the whole level. Here I've created a cozy bakery, where I can eat all the bread I want. And because this is a game, it's 100% celiac safe. For me, yay! So I'm starting to think about game design here. Where are some platforms I can jump to and from? Where could NPCs go to sell some goods? Where might an enemy patrol be? Where could players gather resources? Is this a good spot for players to build a house? How can a character stealth or move around unnoticed? Now use the lessons from the last past courses to adjust lighting, layout, height, and a little bit of calculated clutter. Think about what mood you want to instill into the player. Maybe it's a cozy, happy place, or a little bit dark, gritty, and dystopian. Think about the player's experience you want them to have here. How did they arrive to this town? Did they get captured and put into jail? Did a king or queen demand their presence? You could also even start expanding to the desert area outside the town. Were they epic adventures preparing to find buried treasure into the temple's ancient sands? Or go completely rogue, and the entire place is filled with zombies? Who knows? The endless possibilities are in your hands. That's truly the power of a game designer. Hello and welcome to Visual Effects and the Audio Design Overview. In this module, we will cover the basics of visual effects systems in Unreal Engine and take our initial steps towards implementing audio design. These features will drastically improve the immersion of your environment and impact players' actions. When you hear the background ambiance of a quiet day, or walk by the cracks and sparks of a roaring fire, or even the whoosh of a sword cutting through air, all of these subtle additions will improve the game feel and connectivity for a polished experience. So I'd have to say, let's get immersed.
Let's take a look at what VFX systems are in Unreal Engine. If we go to our Starter Content folder and click on Particles, we can find some visual effects. This is the Cascade particle system and is the old visual effects system in Unreal Engine. You still may find these files in the marketplace, so it's important to understand the difference. The new and updated system is called Niagara. If we click on the content folder for our project and filter by Niagara system, we can open one up to see the difference. Each of these boxes represent a Niagara emitter, while the combination of emitters is called a Niagara system. On the right-hand side are the details for the selected emitter. There's a timeline at the bottom of the screen, and various preset variables on the bottom left, with a preview of the VFX on the top left. Holding down left click in the preview window will rotate around the effect. You can use the mouse wheel or hold down right click to zoom in and out of the effect, and middle mouse button to adjust your camera position in the window. In the Coursera folder, let's make a new folder and label it VFX. To create a Niagara VFX, head down to the FX category. Let's start with a Niagara emitter. Choose New Emitter and select Blowing Particles, and we can name it NE_Blowing Particles. When we open it up, you can see this emitter creates floating particles wisping away in the wind. To better view the VFX, You can adjust the background scene. Go to the window menu at the top and select Preview Scene Settings. Here you can uncheck the Show Environment box to have a black background. Clicking the Bounds button on the top menu allows you to see the perimeter of where the VFX is being played. Now let's check out some of the other emitters. You can create another emitter, this time a confetti burst, naming it NE_confetti burst. As expected, it is a burst of confetti, straight out of the New Year's celebration. Next up is a directional burst, and you can name this NE_directional burst. Some of the parameters being applied, which you can see listed on this emitter, is gravity, forces, and drag, creating a realistic fall to the ground. We will now skip down to a static beam, naming it NE_static_beam. A beam is an emitter that attaches to 2 points in the world. For a static beam, these points won't change and are preset. Now let's look at the fountain emitter, naming it NE_fountain. As you can expect, it resembles water shooting out of the top of a fountain. Next up is hanging particulates, naming it NE_hanging particulates. This one is for a little bit of ambiance with some dust floating in the air, or perhaps it's glowing fireflies in the night. Create the next emitter, an omnidirectional burst, naming it NE_omnidirectional burst. This one resembles a small spark or explosion. The last emitter we will check out is the upward mesh burst. You can name it NE_upward mesh burst. This emitter is different as it uses an actual 3D model as the object. By default, you can see as a bunch of arrows as a static mesh. If you click the bottom segment, the mesh renderer, you can change this. This is the list of static mesh this effect will spawn. You can add multiple static mesh for a bit of randomization. You'll notice with Niagara emitters that you can't drag them into the world. Niagara emitters will never exist by themselves. To use them in your game, you will need to add them to a Niagara system. Right-click and create a Niagara system. For now, just name it ns_test_001. When we open the system up, we can right-click on the grid and choose Add Emitter. Note the tabs at the top. You can pre-select the templates or choose parent emitters for the ones we just created. In this case, I chose the upward mesh burst. You can add additional emitters that add up to a greater effect. I added some hanging particulates to this as well. Niagara is an incredibly powerful system, and you can make very complex or simple VFX. It has a very modular design where you create individual Niagara emitters that form a new Niagara system.
Now that we have created our test Niagara system, let's review the ways we can use this. The most obvious ways is to drag it from the content browser into our scene. We can click the 3 dots by the play button and choose Simulate. This will play the effects in the scene. You'll notice this effect only plays once. Each emitter has its own settings for how often it plays. This can be set to loop indefinitely or set number of times. If we open the ns_test_001 Niagara system, if we click on the upward mesh burst, look for loop behavior settings in the detail panel and change it from once to infinite, compile and save. Now when we hit play, the mesh burst continuously pops off. For now, I'll set this back to once. The next method is to spawn the Niagara system through code. Let's open our character blueprint. In this section for our attack animation code, let's search for spawn system. Note that in the top side that shows emitter under effects category, this is the old system for Cascade and it is not compatible with Niagara effects. The bottom section, which is spawn system under the Niagara category, is what we are looking for. Let's start with spawn system at location. Attach it to the unarmed pin. We will get the actor location and attach it to the location pin. Then search for our ns_test_001 Niagara system we created. Using the 3 dots by the play button, let's set our play mode back to Play in Editor. Now if we use our left click button, it will spawn our Niagara system at our location. Notice that the effect will stay in place once spawned. Back in our character blueprint, let's delete this node and use the spawn system attached. Once again, attaching it to the unarmed pin and choosing our ns_test_001 Niagara system. This time, we won't need a direct location. Drag out our mesh from the component window in the top left and connect it to the Attach to Component pin. Change the location type to Snap to Target including Scale. The attached parent name is the bone or socket you want this Niagara system to attach to. If you click on the bow we created from earlier, you can find a list of available sockets and bones to attach to by using the magnifying glass by parent socket. Just make sure not to change the selection for this bow. For simplicity, we can just type in head to use the head bone. You'll notice it spawns out of the head, but also travels with the character's movement, since the Niagara system is attached to the head. We can go ahead and delete this spawn system attached node for now. Our final way to spawn Niagara systems is through an animation notify. Let's use our bow attack animation montage as an example. You'll notice our scene preview changes we made in Niagara systems are still in effect for the animation preview scene. You can right-click on the notify track and choose Play Niagara Particle Effect. Now here we can choose our ns_test_001 file. I make a few changes to spawn location and rotation to match up in the direction the bow is shooting. When we hit play and swap to our bow, attacking will spawn the Niagara system. For now, let's remove this notify from our montage to clean it up. And now we are ready for the next stage.
Let's take a look at some of the common settings for Niagara emitters. We will create a standalone Niagara system for each one of our Niagara emitters. When you create a system, you can choose to add existing emitters. Choose the New System from selected emitters. Choose several emitters with the plus sign. Once complete, you can click Finish. In this example, I chose the Blowing Particles emitter. Or you can right-click on the individual Niagara emitter and choose Create Niagara System. Let's do this for each of our emitters, but we will change the prefix name to NS instead of NE. When you make changes to an emitter in a Niagara system, it does not affect the original emitter. Making changes to your source emitter will update all Niagara systems using that emitter. Now we can drag each one out into the world and hit play to get a better example of how they look. Let's make a few changes to better view our Niagara systems. On Confetti Burst, change the loop behavior to infinite. Repeat this for the directional burst and raise it up off the ground to see the full effect. Raise the blowing particles off the ground. Raise the omnidirectional burst, static beam, and upward mesh burst off the ground. Change the omnidirectional burst loop behavior to infinite, and repeat this for the upward mesh burst. On the Fountain Niagara system, we can click on Scale Color. Many Niagara systems use curves to adjust various settings. The graph data represents the value and time for this emitter. Let's change the scale mode to RGBA Linear Color Curve. On the top side is the color over the lifetime of the particle. The far left is the color of the particle when it first spawns, while on the far right is when the particle lifetime is coming to an end. Note that each particle spawned will have its own lifetime that can be set through different options. On the bottom is the alpha or transparency. Full white means it is fully opaque, while black means it is fully transparent. If you change the colors, you can see it update in the preview window. Next is the spawn rate. This is how many particles are being spawned. We can lower it down to 1 for barely any, or 1,000 for a massive cluster of particles. Let's leave it at 100 for now. We can now select Add Velocity. Each particle spawned will be randomized a value between the minimum, 500, and the maximum, 850. You can try the extremes by setting the minimum to 1 and max to 10. With no velocity, the gravity and drag will stop the particle and effectively just make it drop to the ground. On the flip side of the extremes, a max of 5,000 will have the particles shooting off into the stars. Let's set these back to the default, 500 and 850. Click on Gravity Forces, and you can adjust gravity for each particle. If we set it to -45, it will not be enough to start pulling down particles and will only slow them down slightly. You can continue to increase this to see the effects. Drag is very similar and affect how far the particles travel. Now let's open up the upward mesh burst. We can select the mesh renderer at the bottom. We can change the static mesh used to anything from your list of assets. Here I changed it to the Staff of Ancients. A mesh burst uses the spawn burst instantaneous, which uses a spawn count instead of a spawn rate. You can adjust this to change the frequency of spawns. Now we can adjust the scale of the mesh size. On this curve, we can simply adjust the graph to change how big or small the mesh is over the course of its lifetime. The left side of the graph is the start of the lifetime, while the right side of the graph is the end of its lifetime. The Update Mesh Orientation segment will change how the mesh is rotated throughout its lifetime. You can change the min and max of the X, Y, and Z to limit which directions the mesh can rotate. Let's swap the scale color back to RGBA Linear Color Curve. You can change the colors or alpha value to make adjustments. While the Niagara system can seem complex, using the module workflow and making small changes to each emitter will add up to a greater visual effect. Let's get some sound effects we can use to implement. We will reopen our crop out example project from earlier. Click on the content folder and filter by sound cue and sound wave files. We will select all of them and migrate to our Coursera projects content folder. Now we will drag that audio folder we just migrated into the crop out sample folder, which is located in the UE folder. Don't forget to fix up those redirectors. We can take a quick look at some of these audio files. Click the audio folder, then filter by sound cue and sound wave. Now to use these properly, let's select them all, right-click, and create a sound cue. We are ready to start implementing some of our audio design throughout our level.
We're going to take a look at a simple way to implement audio design throughout your level. The first is to add an audio component to your player controller, which we now need to create a new player controller. In our Coursera folder, right-click and choose Create New Blueprint class. Select Player Controller. Name it BP_player_controller_Coursera. We can select it in our player world settings. Add it to the player controller dropdown with the arrow button. Let's open up Player Controller. In the component list, we will add an audio component. In the details panel on the right, we will change the sound value to background cue. This sound cue is from the starter content included when we created the project. As soon as we hit play, we can hear some outdoor ambiance. With that simple change, the environment has a completely different level of immersion. Now, let's select the content folder and search for the fire cue. When you hit play is the sound of a roaring fire. I'm going to place this by the oven in our bakery. But think of an area in your level to place it, or create a new one. Let's hit play and walk nearby. You can hear the audio volumes increasing and decreasing based on your distance to the sound cue that we placed in the level. Placing sound cues throughout your level will add up to a larger ambient experience. An immersive world is filled with these tiny additions that add up to the full experience. Let's implement some code to change our music based on the location. We will organize a bit by creating a player controller folder, then moving the player controller into the folder. Then we will need a new interface for our player controller. Name it interface_player_controller_Coursera. Once we open the interface, we can rename the pre-existing function to interface_music_change. Make sure to compile and save. In the player controller blueprint, we will add the interface from the class settings button at the top. Once again, compile and save. Right-click the interface music, change and click Implement Event. Drag out the audio component to the graph and off its pin search for Fade Out. Set the duration to 1. Back to the interface. Let's add an input. Label it Music and change the variable type to Sound Cue. Once again, compile and save. We can slide out the fade out node over and promote the input to a variable. Name it new_music. Copy and paste the audio component again and drag it off its pin for the set sound node. Attach the new_music variable to the new sound pin. Now we can use another audio component. Drag off its pin for fade in, setting the duration to 1. Here, I actually renamed the music variables to music_new. Duplicated it and named it music_current. This reverse naming technique just keeps variables organized when sorted by name. Now drag music_current variable to the graph and choose Set. Duplicate the music_new variable and attach it to set for music_current. This is the basic setup for now, which we will add more to later. Let's create the actor that will trigger the music change. Create a new folder named music_changer. In this folder, right-click and create a new blueprint class, choosing actor as the base. Name this BP_music_changer. This will be very basic, but all we need to do is add a box collision. Let's adjust the box extent a bit bigger, 500 by 500 by 500. We can move to the event graph and delete the default nodes. Select the collision box, right-click, and search for Begin Overlap for the box. Verify Overlap Events is checked. We can also change the collision preset to Custom. Click the Ignore All button and recheck the Overlap Pawn box. Drag off the other actor pin and cast to character, then right-click and set it to Pure. Drag off as character pin and get the controller. Finally, drag off return value and search for music. Select Music Change Interface Message. Right-click the music input and promote it to variable, naming it music. Click the new variable and check Instance Editable checkbox. This will let us edit this when we place this actor in the world. Now we can set up our zones. Let's start with the entrance to the temple. Place the music changer at the front hallway. Then, in the Details panel, set the music to Starter Music. Hit play and run to the temple entrance. It works, but we can make a few more small changes. First, let's add 1 second delay after the fade out. This will make sure the fade out and fade in don't get cut off. We can promote this to a variable and connect both to make sure that they are always in sync. I wonder if that's how the boy band got their name. Name it fadeout_duration. We also don't want this to trigger if the new music is the same as the current music. Let's add a branch just for that. Only continue if the new music is different from the current music. Now we can duplicate the music changer and slide it out of the temple. On the music changer outside the temple, set the music to the starter background cue. Then duplicate both of these and move to each entrance of the temple. We can also move our player's start location a little closer to test. Lastly, copy and paste the default music to the current and new variables. When we walk into the temple, the music will change. then revert back when we leave the temple. This sounds good to me.
If we take a look at the crop out sample sound effects, we can implement a few audio design components. At the bottom, we have various footstep sound effects. Let's implement this to our locomotion. While the sound effect is intended for grass, it does work for our sandy Egypt scene. Always remember that you can use sound effects in any way that it works, and it doesn't always have to be how the sound was intended to be used. Be creative and improvise during development. You can always swap out effects later. Let's start with our unarmed forward run. Our preview scene is still a bit off from when we reviewed the Niagara systems. Let's open up the scene preview and put this back to normal. In the window menu at the top, open the Preview Scene settings. Check Show Environment and Show Floor. Use the quick link to jump to our skeleton, right-click the bow socket, and select Remove All Attached Assets. And now we can go back to the Animation tab. You might have to close down this tab and reopen it to get rid of the bow. We can use the timeline at the bottom to scroll through and find when each foot hits the ground. Right-click and choose Add Notify. We can name it Footstep. Move the timeline to find when the second foot hits the ground. Most walk cycles will have the feet touch the ground twice, but in some cases, there will be more. We don't have to create a new notify each time. Simply right-click and select the footstep notify. Now use the Quick Link tab at the top to swap to our animation blueprint. On the event graph, right-click and search for Footstep. We will add the Anim Notify footstep to the graph. Right-click on the graph and search for Place Sound at Location. We can copy the Get Only Actor node below and paste it above. Drag off its pin and get the actor location. Because Get Actor Location will use the center of the character for its location, we will subtract from the Z value slightly, a value of 100. Connect it to the Place Sound at Location. Right-click on the sound pin and convert it to a variable. We'll name it Footsteps. Right away, we'll delete the variable from the graph. We can change the variable type to an array and then compile. Drag out the variable to the graph, and off its pin, search for a random node. Connect it to the Place Sound at Location. Now we can add 10 different sound files to the array and search for each step sound. There are 10 of them, so we can add each one. Players will often notice repetitive sounds being played over and 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 over. Just kidding. When implementing your audio design, you want to have some small, subtle changes to the audio each time it's played. If we drag off the volume multiplier, search for random in range. We can start with 0.4 to 0.5 and give it a test. It's clearly a little bit too low in volume. Let's increase it to 0.7 to 0.8. Much better. Now the audio seems just a hair off of the footsteps. Let's make some adjustments here. I'm going to move the notify a bit earlier. Now it feels a bit more crisp and on point. Constantly tweaking small changes like this is extremely common. Now we have to go through each walk and run animation and add the notifies to each sequence. It sounds like a lot, but you can copy and paste the notify to speed things up. Once complete, make sure you do a save all. Let's take a listen to our new footstep sounds.
Time to implement some audio for attack. Let's take a look at our audio sound cues once again. We will be implementing a sound for shooting an arrow from our bow. This harvest wood sound will work for what we are trying to portray. The first approach is to just add this sound to the bow attack montage using a place sound notify. We can select it in the content browser and apply it to the sound notify in the details panel. Here is another way we get creative. Adjust the pitch multiplier to change the sound. I dropped it to 0.4 and test the change. A little bit too low there. Let's try 0.8. That seems about right. So let's test it out. Just like with our footsteps, players will notice the repetitive sounds. So let's set up a similar setup to the footsteps system. Delete the place sound notify and add a new notify. This time name it bow_shoot. On our event graph, right-click and search for bow shoot. Select the anim notify. Duplicate the footsteps variable and rename it to bow_shoot. Copy and paste the footstep code to our bow shoot notify. We can remove the change in Z value since we want it to be about the center of the character. Drag the bow_shoot variable to the top of the footsteps variable to replace it. With the bow shoot variable selected, hit the trash can to remove all values. Let's add a few of these harvest wood sounds cues. Move our code upwards. Copy and paste the random float in range to connect it to the pitch multiplier. Set the minimum to 0.6 and the max to 0.8. Now when we shoot our bow, it is no longer a repeating sound. These are simple techniques to create a proper audio design that is interesting and non-repetitive. Congratulations on making it through the visual effects and audio design module. Let's review what we've learned. We've learned that Unreal Engine has a legacy VFX system called Cascade, which was replaced by Niagara. Niagara emitters are single VFX components that can be added to Niagara's system. A Niagara system can be placed in the level, spawned through code, or added to an animation. We reviewed common Niagara emitter parameters, created a Niagara compatible material, implemented basic ambient audio features for the stylized Egypt level, added an audio component to our player controller to handle music and ambiance, created a music change tool that we can place throughout our level, and implemented audio randomization for footsteps and attacks. It's these little extra steps that make your project feel more immersive and polished. Congratulations on completing the Visual Development and Audio Design course. It's common to prototype with placeholder assets or contents that are a bit rough around the edges. We wanted to push it further to create a base that has a great game feel and visual polish. This will help you and potentially playtesters fully grasp if your designs are working or fallen flat. In this course, we reviewed art styles and perspectives, implemented an animation kit and 3D models, explored the basics for VFX and audio design, and redesigned the stylized Egypt level into a template we will use for Course 8, Game Development and Prototyping. This is just the start of the journey to be able to start iterating on ideas with different game modes. Each mode has intentionally very different gameplay experiences. This is a great way to theory craft game designs and initiate discussions around game mechanics. Mixing ideas from different genres is a common way to shake things up and make something feel new again. In the next course, we will continue our journey improving our foundation, this time for our user interface. So let's go!